Welcome back everyone to a session on Unix programming. This will be the continuation of a previous lecture video where we have seen the various IPC methods such as pipes, popen and pclose function and coprocess, right? So in this session we will look into another IPC technique that is FIFO. FIFO stands for first in first out, and these are very similar to that of a pipe but with some advantages. So FIFOs are sometimes called as named pipes. Okay, now pipes are having limitation when it comes to the processes that can communicate with each other, right? For example, a pipe can be used only between a related process when a common ancestor has created that pipe, but that limitation has been removed, that has been overcome when it comes to FIFO. So in FIFO, even the unrelated processes can exchange data and perform this communication. Okay, now let us look into the syntax of creating a FIFO. Okay, so the FIFO is created by making use of the function makeFIFO. mkFIFO stands for makeFIFO, and you specify the path name and the mode to create the FIFO file. Okay, now this path, the path name for FIFO exists in the file system, and the mode, the specification of the mode is very similar, or it is same as for the open function, right? Open function, we have already seen what are the various modes in which I can open a file using the open function. The same modes are applicable with respect to makeFIFO function. Okay, so using this function I can create a FIFO, and it will return the value 0 if makeFIFO is successful in creating a FIFO, and -1 on error. Now let us see what happens when we open a FIFO file and the non-blocking flag, how the non-blocking flag affects the opening of a file. Okay, so before that let us see what exactly a non-blocking flag is, which is specified as o_non-block. Okay, so this flag is sometimes used in cases where one wants to open the FIFO but does not necessarily have the intention to read or write. Okay, yeah, so let us consider a normal scenario first. In the normal scenario, this non-blocking flag is not specified. So in that case, an open for read only blocks until some other process opens the FIFO for writing. So the processes can perform read only until some other process has opened the FIFO file writing, and the same is applicable for write only. So the write only blocks until some other process opens the FIFO for reading. Now what if the non-blocking flag is specified? If it is specified, and open for read only returns immediately, but an open for write only returns a -1. Okay, so this specifies the error with the error number set to this ENXIO if no process has the FIFO opening for reading. So if you try to open write only and there are no FIFO, no processes that has opened the file for reading, then this error will be generated. Okay. And there are two uses of FIFOs. The first one is FIFO are used as a shell commands to pass data from one shell pipeline to another without creating an intermediate temporary files. So this is one application of FIFO, and the other FIFO uses, FIFOs are used as a points in client server application to pass the data between the clients and server. So this FIFO will be considered as a meeting point between the clients and the server to communicate between each other, so that the client can send the request, and the server can send the responses through FIFO. Okay, so these are the two applications of or uses of FIFO. Let us see each one of these. Now let us consider an example where we make use of FIFO to duplicate output streams. Okay, the FIFOs can be used to duplicate an output stream in a series of shell commands, and this prevents writing the data to an intermediate disk file. Of course, this can also be accomplished by using pipes, as we have already seen, right? But there's a shortcoming. Pipes can be used only for a linear connection between the processes, whereas since FIFO has a name, so it can be used for non-linear connections also. Okay, let us consider a procedure that needs to process an filtered input stream twice. Okay, so that is depicted in this particular diagram. The input file is given as an input to the program 1, and program 1 does some processing on the input and gives its output as an input to two different programs, program 3 as well as program 2. So program 3 will obtain its input from program 1, and also program 2 accepts its input from program 1. Okay, so here we don't make use of any intermediate disk file, isn't it? Okay, and this can be accomplished by using a FIFO and another UNIX command called as T. So we should know how, since we already know how the FIFO works, we should understand how the T command works. So T is a simple program, and it copies its standard input to both its standard output and a file name in the command line. Okay, okay, I'll give an example. Yeah, so here we make use of T command. So what does T does? T will get its input from who command. So the output of who using the pipeline is given as an input to T command. So what T does, it whatever the input it gets, it will pass it on to user.txt and to its standard output file. Okay, so one copy of the output of who, which is an input to T command, is given as an output to user.txt, and one copy is given to standard the standard output of the T command, which is the terminal. Similarly, if you specify multiple file names, let me write another one, user1.txt. Again, one copy will be given to user1.txt. So this is how the T command works. Okay, now let us consider one example. Okay, so here what do? We using the mk FIFO, that is make FIFO command, we create a FIFO. We create a FIFO with the name FIFO1, and program 3. So there is one program that takes input from FIFO1. So what scenario I have? A FIFO is created, right, using the make FIFO, and it is its output is given, or program 3 receives input from FIFO, whatever that has been created. So till here we have this scenario, isn't it? Okay, now let us come to the next line. See here, program 1, there is one program, it takes input from something called as in file. So this will be the input file that is given to program 1. So I have program 1 here, prgm1, let me write it as prgm1, and yeah, let me write prog1 to avoid confusion. Okay, and it will receive input from in file. So this is the input file, right? Okay, so this is what we have seen. And the output of program 1, see, the output of program 1 which receives input from in file is given to T using the pipe, isn't it? So this T, what it does, as we have already, we know how the T works. So T will give one copy to FIFO and another copy to program 2. So what will happen? So this is its output is given to T program, and T will give one copy to the FIFO and another copy to program 1, prog 1. Okay, so this is how this can be pictorially represented. So I have already put a diagram. Let us see the diagram. Yes, yes, exactly. So using the FIFO, we made the FIFO to give the input to program 3, and the input file is given to program 1 using the redirection symbol, and the output of program 1 is given to T, and T, what it does, it receive the standard input, whatever it receives, it gives one copy to FIFO and another copy to program 2, right? So this is the diagram how I can represent the series of commands that is written here. So this is about the example of using FIFO to duplicate the output streams. Now let us consider another example of the usage of FIFO in terms of client-server communication. So let us look into some diagram. Yes, so here we have multiple clients and a single server, and we all know that clients will give a request to the server to get some services, and server based on the request will provide services to the or responses to the clients. And using the FIFO, what server has done is server has created a FIFO. Okay, server has created a FIFO, and we call this as well-known FIFO. The reason why it is called as well-known FIFO, because the path name or the path to this particular FIFO is known to all the clients. So this is well known to all the clients. So it is called as well-known FIFO. And each and every client, it writes its request to this particular well-known FIFO. Okay, which is created by the server, and the server will read the request from the well-known FIFO and tries to give the services to the clients. Okay, yeah. Now sending the request is very easy. I can have one FIFO where all the clients can write into this, but how the server will give the responses, that is something need to be addressed. Okay, so can I have a single FIFO where the server can give the responses, which has to be read by all the clients? So is it possible to have such kind of FIFO? It is not possible, because if I have a single FIFO for the clients to read, then the response what the server writes to this FIFO is not known by the client, whether the response belong to itself or to the other clients. So it is not known, isn't it? So it doesn't know when to read and when not to read, or whether it is reading the responses that belongs to the other clients or to itself. So this kind of scenario is, or this kind of arrangement is not possible. So what we need to do? So this can be overcome with this particular diagram, okay, or this particular arrangement. So what client has to do is, client along with the request what it writes to the well-known FIFO, it should also write the process ID of that particular client. So along with the request, the process ID is also mentioned, and it is stored in the FIFO. So each and every client will be having its request along with the process ID. Now what the server will do is, server will read the request along with the process ID. So based on the process ID, what server will do is, server will create individual client specific FIFOs. Okay, so client specific FIFOs will be created, and this client specific FIFO is based on the process ID, and the client will be able to read the replies that has been written by the server to this client specific FIFO, and this can be read only by the client that has sent the request along with the process ID. Okay, so other clients will not be able to read others client specific FIFO. That is not possible. So using this arrangement we can solve this issue, right? Yes. So this is how the FIFO can be used in a client server communication. Okay, so using the server will create a well-known FIFO, and to this well-known FIFO all the clients will write a request along with its process ID. the server will read the request from the well-known FIFO, and based on the process ID and the request what the client has given, it will create a client-specific FIFO and it will write the replies. And the client will be able to read from the client-specific FIFOs and get the services from the server. So this is how, using a FIFO, we can accomplish client-server communication. So this is about inter-process communication method by using FIFO.